Hi, if you're a beginner in computational chemistry and want to do computational simulations such as density functional theory, aka DFT, and AIMD on amorphous structures, this video is for you. Today I'm briefing on how to convert a crystal structure to amorphous computationally. I'm going to use an example of germanium from my publication, a link for which is given in the description section below. So I wanted to do a certain set of simulations on amorphous germanium. While crystalline structure of germanium is well accessible in material databases, amorphous structure we had to obtain via process of computational quenching. For those who don't know what quenching is, quenching in material science involves heating of material, or rather melting of material, and then very rapid cooling. This process is commonly used to alter phase and mechanical properties of the materials. To convert a crystal structure to amorphous, crystal is first heated at a very high temperature which is far above its melting point. Now this is done for a certain time span. This can be done using molecular dynamics approach. In present case study, the crystal germanium was heated up to 5000 Kelvin. This high temperature provides atom with excess kinetic energy to break orderedness and shake things up. This is followed by very instantly cooling of material to room temperature. This sudden drop in temperature from 5000 Kelvin to 298 Kelvin does not provide atoms sufficient time to recrystallize to their kinetically favored positions, and therefore randomness of the structure is maintained. And lastly, we DFT optimize the final structure and confirm whether the structure is amorphous or not by measuring the bond lengths or doing radial distribution function analysis. Now for more details, you can refer to the supplementary information in my paper. The link is given in the description section below. Thank you for watching this. If it was helpful, please like, and if you want to see more of such short videos, please subscribe.